Hello, Miss Aaron, Miss Ryan, alright?
How are I gonna put the TV as a computer? I just realised they're not. I gotta put it on the floor or on the table.
Yeah, we'll figure out. Okay, so today we're given a few integers, positive integer. Yeah, we're given a few
1,
positive
3, 2,
integer.
4, 3, 5.
Okay, 1, 3, let's say 1, 3, 5, 7, right? These are positive integer, non-negative integer, okay? Non-negative integer. If we convert them into binary,
1, 1, 0, no, 1,
Okay, so this one.
1, 1,
this is 1, yeah? 3,
101. 5 is 101.
and 7 is 1, 1, 1,
7 is 111.
1.
okay? So the question is that can we find any two numbers in the array? Then we perform this OR, bitwise OR. Bitwise OR. Remember what's OR? What's OR?
Doesn't matter if one is positive or the other is positive. If one of them is positive, then it will be.
Okay,
1.
so what value should I put?
0 and 0 is 0. 0 and 1 is 1. 1 and 0 is 1. 1 and 1 is 1.
That's right. Okay, that's bitwise OR. Okay, so if we pick two numbers from the array and you perform this bitwise OR, okay, we want to find out if it's possible to find such pair that the bitwise OR has trailing zeros. Okay, trailing zero. What does it mean by trailing zeros?
Lots of zeros in a row.
Zeros. Okay,
In a row.
trailing zeros. What does it mean?
Zeros in a row.
It's a number followed by a zeros.
A number followed by 0. Yeah. So what happens if we have a trailing zero for any numbers here?
Is even.
Even number. Yes,
Because
even
if
number.
it ends with 1, then it has to be all even, and then plus 1 makes it odd. But
Yeah.
else it'll just at even plus.
Okay, so for example, given this 1, 3, 5, 7, can we find two numbers in this array that the bitwise OR has trailing zeros here? Come on, obviously, these four numbers, can we find any two numbers that we perform the bitwise OR? Remember this OR thing? It
No.
has. So this question, right? In other words, we are trying to find out if there are two even numbers of the array. Am I right? Can I rephrase it this way? Yes? Okay, so remember the question is that can we find two numbers in this array which contains non-negative integers that the bitwise, when we perform the bitwise, has at least one trailing zeros or all trailing zeros, okay? As you agree, the trailing zero, if a number in binary has a trailing zero, it means it's even number. So if it's an odd number, if one of number is odd number, right? When it performs a bitwise OR to other number, it doesn't have trailing zero, am I right? Because 1 bitwise OR anything 0, this is 1. 1 bitwise OR bitwise OR 1, this is still 1, right? The only case when it has a trailing zero is 0 bitwise OR 0 becomes 0. Okay, so it has to be two even numbers. So this question is the same, equivalent to finding counting, right? Counting the number of even numbers. So we want to find out if there are at least two even numbers in the array. Am I right? So once we get that, this is super easy. Alright? Okay. So
everything is easy.
yeah, but this one is super easy. So we want to find out if there are two numbers which are even number in this array. Okay. Define F array. So even at the beginning equals 0. For I in array, how do we find out if a number is even number?
Modulus.
Yeah, modulus or perform the end one, right? It's the same thing. N1 equals 0. Basically, this means that we look for the rightmost bit, least significant bit, to check if it's a 1 or 0. If it's 0, it's even number. Okay. If I modulus 2 equals 0, then even plus equal 1. Okay, and then return even bigger or equal than 2, right? Time complexity. Time complexity.
O-N.
Space complexity.
O-1.
Well done. Okay. You're pretty good at this. So this is the code, right? So simple. We go through the numbers. Each number we count if it's a even number or odd number. If it's even number, we increment the counter. can we improve on this? Just imagine if we have a million numbers here. Do we need to finish counting all of them? Do we need to finish counting all of them? At least 2 even numbers. So do we need to find out, go through all the array numbers in the
No,
array?
you just need to check the small error because if you count 2 even numbers, you don't need to keep on counting one more.
That's
Because
right.
it
Yes.
doesn't matter because it will still be 2 even numbers.
That's
anyway.
right. So the only thing we can improve here, that we can improve is that adding here. If even bigger or equal than 2, then we can here return true, right? And that's it. And then here we just change it to return false, right? Because as long as we have found 2 even number, we can stop counting. Okay? So the time complexity is still on, the space complexity still 1. Why still on? Just imagine in the worst case, only the last 2 numbers are even number, right? So there are a million numbers before a million odd numbers before the last 2 even number. Okay, so this is the traditional way to count if there are at least 2 even numbers in the array, and obviously we can do it shorter using the fancy syntax. Return sum I modulus 2 equal 0 for I in array, right? And then we need to check if this sum is bigger than equal than 2, okay? But in this case, we can't apply this optimization here, okay? If we change this to n, what values do we need to change? If this is n, both needs to be true in order to be true. So only here is 1, all the rest is 0, okay? And how about exclusive OR?
Exclusive OR means that 0, 1 or 1, 0. 1.
Yeah. So only
If then no numbers can be the same.
okay, if they are different, there's 1. Otherwise, if they're the same, there's 0. Okay. Okay. So what have you learned today? That's it. What have
We
you
don't
learned?
really learn anything. We're just looking at things.
Okay. So can you describe to
I
me?
think you need a word there. Not what have you learned today. It should be what have you been doing today.
Okay. What have you been doing today? What have you been doing today? So can one of you describe what's the
It's not
problem?
you, it's we.
Okay.
What have we?
What have we learned today? What have we been doing today? Anybody? One of you described the problem. One of you described the solution. Please, and that's it.
We want to check if there's 2 even numbers.
Okay.
Or
This.
more, 2 or more even numbers in a list of positive integers.
This is not original question. The original question is that if we can find any 2 numbers of the array,
Bitwise
or
training
trading 0. So this is the same as finding 2 even numbers if there's any. Okay. Okay. So the solution is
to find 2 even numbers.
okay. That's very straightforward. We just go through the array to find out. Yeah. Simple as that. Okay. That's it for today. Bye bye.
Bye.
Bye bye.